working in cloud domain. My background is telecom. So today we are going to learn about OpenStack. Today we will be knowing about OpenStack. This is a technology which is helping us building our cloud. So first we will know about what is cloud computing, OpenStack history and version, why OpenStack we are going to use, and OpenStack architecture. It's a very simple diagram to make you explain you that what is cloud computing. We have application, we have platform, we have infrastructure. It is located in central place and we can easily access it. So everything will be kept in a central place and we can easily access our storage, our application, our platform. So it saves our time. It is very flexible. We can main thing is that we can use proper resources, saves energy also. Suppose if we have a central place, we have a data center in a central location and we are running 100 servers. We don't need to split it different location. It will be located in a central place and we can easily use all the resources, all the infrastructure from one place, and we can build our cloud and we can access everything, means like our application, our infrastructure, means platform, as well as our database. So this is what about cloud computing. So you can see application, platform, object storage, block storage, everything in the picture you can see here. Okay, so you can access from your laptop, you can access from your desktop, you can access from your tablet or any service. Cloud deployment models. What are the cloud deployment models? We have three types of cloud deployment models. One is hybrid cloud, private cloud, and public cloud. When we combine private cloud and public cloud together, it becomes a hybrid cloud. And private cloud, it is for internal access, means like intranet, right? And suppose customer doesn't want to expose their network to outside world. So this is called private cloud and it is very secure. There is no any problem. Suppose if you want to run your banking cloud, so in that case you need to build your intranet. Private cloud, telecom cloud, if you want to build your telecom cloud, then that is also very that you need your data privacy should be there. Security compliance should be managed. So in that case you need to build a private cloud. Public cloud, that is nowadays we are using AWS and all. In that case also we have some, they are also providing private, or they are also providing for, if you pay extra money, they are also going to provide you some security purpose, security compliance and all. So nowadays telecom companies are using private cloud, they are building your own cloud. Private cloud means building your own cloud for your own purpose. And public cloud, it is exposed to outside world or a provider network and it is accessible to everyone. Four types of cloud service model are there. Private, on-premises, infrastructure as a services, platform as a services, and software as a services. This is also known as in a short form AaaS, PaaS and SaaS. So private cloud, when you are building your own cloud, then everything will be managed by you. Means application, security integration, database, server, virtualization, server hardware, storage, networking. All the things will be managed by you. When you come to infrastructure as services, then networking, storage, server hardware, virtualization and servers, except blue ones, that is going to be managed by a vendor. Okay. You are going to purchase these things from a vendor, means you are going to pay them purchasing these services. Like you will not have your own service, you will not have your own hypervisor, storage, networking, that will be managed by your vendor. See here it is written in blue color, it is managed by you, and in this color, gray color, it is managed by vendor. So you only need your database, application or runtime and security integration. That is your own, means you need only these things, and you will ask the vendor that I need I need infrastructure, and on infrastructure I am going to run my own application. This is called infrastructure as a service, platform as a service. So in this case yours will be only application and you are going to run on platform, means like database, server, virtualization, security integration, everything will be provided by vendor. You just need to run your application, means you are going to launch your application on platform as a services. Software as a services, coming to last one, software as a services. So here everything is going to be managed by vendor. Nothing is going to, means like suppose you open Citrix, for example, Citrix, Concur, many tools are there which is managed managed by vendor and you are just an end user, you are going to use it. Hope I am clear. This all four models. Shall I explain it in a deeper way? Now, infrastructure as a services, platform as a services, software as a services. For example, any application which you are using as an end user, and you don't need to know where this application is launched and how this application is going to be managed. You just need to use that application. That's it. And it is completely managed by vendor. Means from infrastructure to application. So everything is going to be managed by vendor. You just need to use it. That's it. This is the software as a services. And platform as a services I've already explained you, and infrastructure services. These are the service models which you can buy from a vendor. In private, you can build your own cloud. OpenStack community, many communities are working on OpenStack to make it better and make it larger and make it more advanced. So NASA, Merentis, OpenStack means two vendors are working on OpenStack. That is, one is Red Hat OpenStack and one is Mirantis OpenStack. Two companies are typically providing their services in OpenStack, but here we are going to learn RHOSP, that is Red Hat OpenStack. See, OpenStack history and version. Simply how to learn history and version OpenStack. Suppose someone asks from where OpenStack started and what is the first version. So just know the alphabetical order, that is A, B, C, D. So in 2010, the first Austin was the first version which was released in 2010, and it is started with alphabetical order A. So A, B, C, D, E, F. So it is completely A, B, C, D alphabetical order. So currently it is means in 2020 Victoria is the release which is going to be released in September. So these are the versions which you can know. So why OpenStack? Why we are going to work on OpenStack? Like suppose somebody asks why you are working on AWS, why you are working on GCP, and every technology has their advantages and pros and cons. Okay, so why we are going to use it over? Why we are going to use OpenStack? Or see, first advantage is that you can create your own cloud, that is private cloud. You can create public cloud. You can create hybrid cloud. All the three model it is going to support you. Which language it is UI, the user interface is easier to use. You have a different VM placement policies. You can spawn your VM with a different placement policies. KPIs you can maintain SLAs and provide to customer. These are the features which OpenStack is going to provide you. So coming to OpenStack architecture, I will tell you flow, how this flow works in this picture to make you understand in a better way. So suppose if a person want to launch a VM or spawn a VM, so there are different services like we have in AWS as well as in GCP. But logic is very simple. Only terms are different. For authentication, here we are going to use Keystone, Nova for spawning our VM, Neutron for networking. Suppose if you want to launch a VM, so you need services. Okay, right. For authentication, you need Keystone. For spawning or launching a VM, you need Nova services. Providing a networking to your VM means suppose if you want to access your VM, if you want to provide internal network or external network, in that case you need Neutron services. Neutron services is going to help you to provide a networking services. Glance is for image. I will tell you all the services one by one, better way. But for just explaining this diagram, I'm explaining you. So glance is for image. Swift is for object storage. So let me start with the flow. Suppose if a person says launch a VM. So first thing, it is going to take a authentication or authorization. Suppose if you want to launch a VM, so first it will take a authorization permission that it will know that this person is user of this technology or not, is user of this project or not. Okay. It will first take authorization from Keystone, then it will ask a Nova service to know where to launch this VM. Means it will find a resource. It will find empty resource where it can launch a new VM. Okay. Once it will get a place or a node, then it will see. Here it is saying, right? Okay, we need to find a place to build this VM. In Keystone, it is asking, need to see some papers. Means it is saying that I need to see where this person is registered with us or not. This person is authorized or not. So after Keystone, it will go to Nova. It will find a place where it should launch a VM. It will get a node. Then it will get a node. Once empty places will launch a VM on this node. Neutron, I need a network with all the, so it will ask to Neutron, I need your help to provide our networking access to our VM. So it will take help from Neutron for networking access. So these are not enough to launch our VM or use that VM. We need image also. We need data for sender also. Sender is for block storage. So it will take all these things. It will take block storage to store objects or a data inside that VM. Glance is for image. So this is the flow, how it works. So Keystone, Nova, Neutron, Cinder for block storage. Swift is for object storage, Glance is for image. You need some OS, right? You need CentOS or Red Hat. So Glance is going to provide you that image. So after getting that image and after getting networking services node on which you are going to spawn your VM and taking block storage, that is Cinder, help for storing your data on the particular VM, then easily your VM is spawned on launch and you can easily access from external world or internal world, right? So this is a request flow, how it requests all the services. Coming to all services, how the services are there, means dashboard. Dashboard is Horizon, which provides a web-based self-service portal to interact with underlying OpenStack services. OpenStack is having these services, and with the help of these services, you are going to build your own cloud. Dashboard is a GUI-based service that we call it Horizon. With the help of Dashboard, you can build your own project, your own tenants. For example, I will tell you, suppose packet core or data service. Data service is different, multi-service is different. All the services are different. So for different services, you can build your own project, means different projects with the help of Dashboard. So Dashboard is going to provide you a web-based self-service portal to interact with underlying OpenStack services. With the help of Dashboard, you can take all the services help, means like compute node. I told you last slide I will move. Compute node is nothing but it is a bare metal server. These servers we are going to spawn our VM, and this is going to be managed by Nova. Nova manages the life cycle of compute instances in an OpenStack. See, Nova service, Nova Keystone, after authorization from Keystone, it is coming to Nova. And Nova is finding out the node where the VM is going to spawn. Nova is finding the node, means compute node. Compute node is nothing but your bare metal server. Server is there, right, on top of it to spawn your VM. So simply it is manages the life cycle of compute instances in an OpenStack environment. Responsibilities include spawning, scheduling, and decommissioning of virtual machine on demand. Neutron, I told you, Neutron is going to provide you networking services. See, after getting our node where we can launch our VM, we are coming to Neutron services for asking for default route or firewall setting or IP. Enables network connectivity as a service for other OpenStack services such as OpenStack Compute. Provides an API for the user to define networks and the attachment into them. Pluggable architecture that supports many popular networking vendors and technology. That means it means to say that you can enable network connectivity as a services. You can provide connectivity to your VM and you can access your VM from internal network as well as external network as per your feasibility, means what is the requirement. Coming to storage services, there are two types of storage and object storage. Object storage is provided by Swift service and block storage is provided by Cinder. Node is asking, have that volume ready for me. Means it is asking, means volume is ready or not, so that VM can use it, right? That VM can use it and end user can store that data on the Cinder volume. So we need some volume to store our data. So it is provided by Cinder. So I will tell you what it is written. Provides persistent block storage. Cinder provides a persistent block storage. Once you delete a VM, then your volume will be there. It will be not deleted. It will be there. You can restore your VM with that particular volume. So provides persistent block storage to running instance. Pluggable driver architecture facility that creation and management of the block storage device. Object storage is provided by Swift. It stores and retrieves arbitrary unstructured data objects, RESTful HTTP based API. It is highly fault tolerant with a data replication. So Swift provides object storage, right? Object storage we can use either, means for storage you can use either object storage, either block storage. Both storage means as per your requirement you can use any of the storage to store your data. So now moving ahead, keystone that I have already told you, for authorization and authentication purpose we need keystone. For using any of the services we need keystone permission to use. See, keystone provides an authentication and authorization service for the OpenStack services, provides a catalog of an endpoint of all OpenStack services. It provides a catalog to all endpoint services of OpenStack. Glance stores and retrieves virtual machine disk image. OpenStack Compute makes use of during instance provisioning. Okay, Glance provides a image service. So see, hey Glance, can I get the RHEL 6.4 image? Means you need some image, right? Image means you need some OS to install on your VM so that you can run your application on top of your VM where OS is running, right? So any image, that can be any image, RHEL 6.4 or Ubuntu or Fedora, any image you can use. Okay, so but that image can be used, or that service can be used via Glance. Glance is going to keep all those images, and you need to ask Glance to provide that image. Means first you need to upload your required images in Glance service. Then from Glance, as per your requirement, you can take any of the image to spawn your VM. So this is what about Glance. Cellulometer. Cellulometer is metering service that provides you the metering or monitoring meters of OpenStack Cloud for billing or benchmarking, scalability or statistical purpose. Cellulometer is going to provide you a KPI, means like CPU utilization, RAM utilization, disk utilization. So it is going to monitor all the resources of your cloud. So this is provided by Cellulometer service, same keystone service. How we can build our cloud with this, the help of these services. Any doubt on these services, please let me know.
Okay, only one doubt. Other than that, if you have mentioned some Nova, it has compute personal. Other than that, Nova services, we have some other computer services other than that Nova.
Nova Conductor, Nova Scheduler. These are the in-depth, means once you start your course, then you will get to know all the services, what are the purpose of the services. These are the basic services which you are going to use and you can launch your cloud. So Nova Scheduler is there, Nova Conductor is there.
Actually, it doesn't mean that. Other than Nova computational services, like that, any other services you have for computational process?
Only Nova. Nova is responsible for managing the life cycle of compute. Nova is the only services. No any alternate way to manage your life cycle of the compute. I will tell you, suppose if you want to build your cloud, OpenStack RHOSP, then you need undercloud, overcloud. With the help of undercloud, you are going to build your overcloud. Overcloud means compute nodes, controller nodes. So what is compute node and controller node? I will tell you. These are the for building your cloud you need three things: compute nodes, networking, and storage. Okay, compute nodes you can build with the help of bare metal, any HP, ProLand servers, IBM servers, any servers. You need that server hardware you need, and second thing you need hypervisor for making for providing virtualization to those hardwares. Third thing you need storage, and fourth thing you need networking. Networking switches you can use any NRU switches, Pluribus switches, Juniper switches, Palu switches, any switches you can use, Cisco switches. Top of your hypervisor, generally many telecom providers are building their cloud with the help of using hypervisor, that is known as KVM. On top of the KVM they are building their cloud. KVM is a hypervisor. There are many different types of hypervisor in the market. Like KVM is there, VMware is there, okay, Citrix is also there, many hypervisor is there. So for building OpenStack cloud we are using KVM. For KVM we are providing virtualization to our hardware. So there we are going to build compute nodes, controller nodes. These all services what I have told to you, like Nova, Neutron, Swift, Cinder, Keystone, Glance, these all the services is going to run on your controller node. So controller node is like a brain of your OpenStack, and it is going to cater all the services. It is going to run all the services in the controller node, and this controller node is going to manage all the computes.
But we don't have any separate distro, right? Like only we can have a compute node only. Other than that, we can have a storage node. Like
See, for your requirement, you can use hyperconverged storage, you can use internal storage, you can use external storage. So it depends upon it depends upon the customer requirement. Means what customer wants. If you want to build internal storage, no problem. You can use Cinder service, and you can connect your external storage to it. If you want to use EMC Square as an external storage, or Nexenta, or any other storage, if you want to scale IO, any other hyperconverged or external storage you want to use, you just need to interact with the OpenStack services, and it will provide a connectivity to your external or internal storage, and you can easily access to that storage system. Actually, this is an open source, right? So it provides feasibility to use vendor specific hardware you want to use. Any hardware you can use, any type of storage you can connect, any type of networking system you can connect. So it is very feasible. Means all drivers supports OpenStack. Even you can use Cisco switches, you can use pluribus switches, you can use any ALU switches or any OEM switches you can use to provide your networking. Just you need to interact with Neutron services for providing those services, providing networking part. Okay, like same as what I have told for storage. Any OEM you can use, any vendor you can take from the market. EMC you can take Nexenta, you can take any vendor for storage purpose. So this is the beauty of this OpenStack. It is open source and you can use as per your requirement.
I had a question. When you had storage, right? You have two types of storage you talked about. That is that persistent storage, and then the other one is the object storage, right? Swift versus Cinder. Does Swift also provide persistent storage, or Swift is an entirely different concept than Cinder?
Both are different concepts. For example, I will put an example here. Okay, you have used RDBMS, right? RDBMS, what RDBMS uses all the relational tables. If you want to retrieve any data, give a reference to that particular table. That particular table will be your reference, and from that particular table, you are going to take your data. This is completely relational based. Means block wise, everything is kept in a block wise. Object means, suppose example, in your laptop you have kept your movies, pictures, everything. So there is no segregation, right? Everything is kept in a single table, and you need to take it from there. So it takes time to retrieve those data. Means take those data. There is no, see here it is written, right? Stores and retrieves arbitrary unstructured data objects. Unstructured means there is no any structure for keeping those data. Everything is placed in anywhere, means you don't know where it is kept. But in block storage, everything is placed in a proper way, in a proper manner. It is structured data. For example, I have given you like RDBMS. There is table name. From that particular table only you are going to take. So it is very fast and easy, right? You can easily accessible those data if you know the table name.
Okay. So what you're saying is persistent block storage is something like hierarchical. Like you have a master, and then from the master you can go down, and everything is interrelated. So you can go using the indexes and all that. You can straight away get to the data that you require. Whereas in unstructured, you don't know. There is no structure. There is nothing. You don't know where it is stored, how it is stored.
Yeah, exactly. Absolutely. This is the advantage of block storage, and you can say that is the disadvantage of object storage. As per your requirement, you can use either of them.
One more question. That means that block storage, would it be faster than Swift? Cinder then would be faster, right? Because if you take example of the RDBMS, have to get to the correct table, and then that table will have a pointer to where the data is, or whatever the hierarchical structure is, right? But then Swift will not know that.
Suppose means nowadays all the telecom companies are using block storage only, Cinder only. They are using Cinder because for VoLTE services, like this is a VAS services, right? So data read and written in seconds, microseconds, right? Here we are forced to use Cinder service only, because we need to write data in a microsecond. Read, write. Accessibility of data is very fast. So we need to use some storage which is going to provide high accessibility, right? So we are going to use block storage. Compatibility is also there. Hardware, you have to use that kind of hardware only, then your cost increases.
So Cinder means you will use something called SCSI, SCSI, or that type of technology, or?
Correct. SCSI, iSCSI, you need to connect. NFS also you can connect. NFS storage also you can provide. After completing this course, complete administrator course, Red Hat OpenStack course. We have having two books, CL110 and CL210. Currently, version 3 is the latest version. Previously, the student which they have given on version 10, that is global certification. So I will provide assistance if anyone is interested in giving a global certification exam. I can help them, and definitely I will help them to prepare for the exam.
I had a question here, Ashwini. Yeah, version 10 you said, right? But I heard that version 13 is the latest one where the like say I guess all of us are going to attempt for OpenStack the OpenStack administrator certification with Red Hat, right? But that one, I believe that it is in version. It is a more recent version. I think version 12 or version 13. I'm not sure. But then, how will we scale up? We have to, read. We are going to be trained on version 10. And then we find out that in version 13 there are certain changes which one of my friend who took his very just recently about a couple of weeks ago he has taken the certification. He flunked in the certification because there's a lot of differences between version 10 and version 13. So my question is, we are still stuck on version 10, but the certification is on version 13. How are we going to bridge that gap?
See, this is an old slide. Okay, so just now I have told you about version 10 as well as version 13, right? There is no any big difference in version 10 and version 13. I will tell you what is the difference. In version 10, you are going to learn about containers, little bit about containers. In version 13, you are going to learn about containers. In version 10, you are not going to learn about containers. This is the difference. What is version 10 and what is version 13? Both the courses are very similar. Nothing, no differences. Only just exam point of view, preparation should be in a different way so that you can crack your exam. That I will help you in preparing your exam. Need not to worry about that.
Can I just further probe on what is when you said you will help us in preparing, what is the what do you have in your, what is the vision you have in your mind of thinking that this is what I will provide so that the people can crack the certification exam? What is the
lab practices? As much as more lab practices you will do, you will be more expertise and you will have high competency level. I will help you to build your own test lab in your laptop. If you have 8 GB RAM laptop, then definitely I will help you to make your own test lab in your own laptop so that you can have accessibility anytime as you want. So you can easily do your lab practices on your own laptop itself.
On the same line, next question with that lab thing is that the lab thing, to be very honest, right? You have the OO OpenStack, right? Using PackStack, you can install OpenStack using through that OO, right? Whereas that OO thing will not, even though you can download OO and you can go over it and all that kind of stuff on a Red Hat environment, it will not be OpenStack because whatever Red Hat is doing will be different. So how is your lab assistance that you're giving, or you're saying that I will help you set up the lab, how is that different from what we are getting from outside? Like, I just gave you an example. You have Mirror is also giving you their OpenStack, right?
Yeah, correct.
So that's my question.
Two types of lab setup is there. One is all-in-one, like you can install all-in-one in your laptop, means everything, your controller, your compute nodes will be in one virtual machine itself. And different lab setup is like you need to build individual nodes, like compute nodes different, controller node different. This is the second type of a lab setup. So I will try to help to build both the lab setup, like you can build your own in a cloud environment and all-in-one as well as in a different nodes also. This is your question. Which type of lab setup we can create?
That is correct. Going more into that line, right? If you look at that CL10, CL110 and CL210, right? They have in CL110 and 210, you'll be I'm sure you'll be showing us the study guide, right? That's the study guide which shows you that you have you have a virtual machine, and inside that you have one bare metal server, and inside that you have all the virtual machines, and they have all the different complicated network of how they have set up, like what is your 172.172.16 subnets and how that is set up and all that. My question is that to be able to work on the lab, right? I need to have that exact lab set up with me. Otherwise, how will I work? How will I do the work guides and all that? So my question is, will you be able to give us that kind of an environment, like where it is exactly apples to apples of what is there in the lab book? I mean, doesn't matter. Version 10, version 13 is going to be the same, like you said. That doesn't matter. But the lab book that you gave and the virtual machine that you gave, both of them needs to match. Otherwise, it will be a very big task for the students, for us, for people like me. It will be a big task because then I'll have to map everything and all that. So what is the approach you have on that?
Yeah, definitely. We are going to completely follow the book of Red Hat, right? The exercises which will be available in the book, that we are going to follow it. Means that we are going to practice it. Because without those exercises, we won't be able to clear the exam. So completely we are going to follow Red Hat book, nothing else.
Okay, which means that the virtual machine or the all-in-one that you give will have exactly the same configuration that is in the book, or will it be slightly different?
Yes, same. We are going to completely follow the book.
And one more question is, you gave me this virtual machine, right? Now, after the course is over, will that virtual machine expire itself? Like you say that, okay, you are only allowed to do 30 days. After that, your virtual machine is no longer available.
It is not like that. So I will also demonstrate the project telco, how telco clouds are deployed. So even I will tell you this is not in the course, but definitely this is going to give you advantage. If you are from a telecom background, then definitely I will try to explain different telecom clouds. Because nowadays all the telco operators are using their different vendors, and all the vendors have customized their own cloud. They have built their own product with the help of OpenStack. Like Cisco, they have their own product of cloud. Ericsson is also using their own cloud. They have built with the help of, but the technology is same. That is OpenStack only. But they have built their own cloud. Nokia have also built their own cloud. CBIS, in Nokia they say CBIS cloud band infrastructure. If you are interested, then definitely I will tell you the telco clouds. Lab setup, I already told you. I will help you to prepare a lab setup so that you can use it for a lifetime. That's it from my side. Any question, if you have, you may ask me.
Course timings and all that, we will discuss it with MindMajix, right?
Yeah, sure.
Yeah, actually, you told I will try to give a training in cloud setup, and actually, which kind of cloud you will be prefer, because of we plan to use Google Cloud, means you will be provide the training over there, or else how it will be?
I will be building a private cloud, and I will help you to build your own private cloud also. So on that private cloud, you can practice your book exercises as much as you can. And second thing, I will demonstrate you the telecom operators, what telecom operators are using nowadays, which kind of cloud. They are using same OpenStack cloud only, but they have customized, a little bit customization is done by them. So even I will tell you the architecture. Nowadays, many companies are using OpenStack, but if you see, most of the telecom companies are using OpenStack, and they have built their cloud in their style or in as per their requirement. I said simply that I will help you to understand their architecture and how they are using for VoLTE services, packet core services, and 2G, 3G, everything. They are like previously legacy network was there, right? Bare metal hardware they are using for running those services. But nowadays they are moving to cloud for running those services. So in that point of view, I told you that I will help you to understand the architecture of telecom cloud. Telecom means nowadays in India, Airtel, Bharti, Vodafone Idea is there. So they are running their own setup of cloud. Okay, previously they were using hardware. Now they are building their cloud for running VoLTE services. VoLTE in your mobile, VoLTE services there, right? SMS voice services there. So for running this service, they are also taking help of cloud. They are putting their application on cloud to reduce the cost, energy.